Hello everyone. Today we will discuss some numericals based on superposition principle. So let's take first question from NCERT. This is example 1.5. It says that three charges Q1, Q2, Q3 are placed at the vertices of an equilateral triangle. And one more charge is kept at the centroid of this equilateral triangle. What is a centroid? Centroid is the intersection point of the medians, but if it is an equilateral triangle, then the medians and the perpendicular bisectors will be same. So if this is the equilateral triangle, then this will be the median as well as the perpendicular bisector. Similarly, this. So this is D, E, F. These are perpendicular bisectors. This is the centroid which is marked as O over here in the book. And if this is centroid, then AO is equal to 2 by 3 times of AD, because centroid divides the median in the ratio 2:1. So if this is 2, this is 1, that means 2 part out of the complete AD. And how will I write AD? AD can be written as, you know that this will be 60 degree. So this half angle will be 30 degree. So between AD and AC, what will be the relation in triangle CAD? Cos 30 degree is base upon hypotenuse. So the base is AD upon hypotenuse is AC. So therefore AD is equal to AC cos of 30 degree, and this is AC is the side of the equilateral triangle is L. So that's why AC is L, cos 30 is root 3 by 2. So therefore AO is equal to 2 by 3 of AD. This gives 2 by 3 of L root 3 upon 2. So this gives me L upon root 3. And we know that this is an equilateral triangle. So AO will be equal to AO is equal to BO is equal to CO is equal to L upon root 3. Right? Let's find the direction of the force on the charge capital Q which is placed at the centroid. So what we have to find is F net on Q at centroid. This is what we have to find out, right? Now we have to check first the direction of these forces. Now force on this charge due to the charge at A. These charges are given equal. That means at all the three vertices, the equal charges q, small q are kept and capital Q is kept at the centroid. We have to find the net force on this charge which is placed at the centroid. Now, we have to find the direction of force on this charge due to A. We'll mark that force as F1. So, this charge will repel this because both are positively charged. So, this will try to throw it away from it. Now, this charge will also repel it. So, this will try to throw it away from it. This is the charge at C. So, we are marking this as F3. Now, this charge will also try to throw it away from it because of repulsion. So, this will be F2. Right? Now, we have these three forces. This is F3, this is F2 and this is F1, right? This is already vertical. We have to find the resultant of F2 and F3 using parallelogram law. So, this we will get by using parallelogram law. So, here I am marking that this Fr is the resultant of F3 and F2. How will we find? We will find this by using parallelogram law. So, what is parallelogram law? If you remember, if we have these two vectors which give the adjacent sides of the parallelogram, then the resultant is given by the diagonal both in magnitude as well as in direction. So, this formula, the magnitude of the resultant was given by under root of first vector square plus second vector square plus twice of magnitude of first, magnitude of second into cos of angle between the two vectors. If this angle between the two vectors is given here by theta, right? So, in this case, if I have to find the resultant of these two forces F3 and F2, the angle theta will be 120 degree, right? So, using parallelogram law, I will first find Fr. So, Fr is equal to under root of F2 square plus F3 square plus 2 F2 F3 cos of 120 degree, right? So, this we can put the values. We will first find F1 magnitude, F2 magnitude and F3 magnitude. Let's find this. So, F1 magnitude, these are the magnitudes only. So, F1 magnitude, if I am not marking the vector sign, this shows that this is the magnitude only. So, this will be K Q1 into Q, that means Q into Q. So, capital Q into small q upon AO whole square, right? And this can be written as K Q Q upon AO is how much? L upon root 3. So, this is equation 1, this is 2 and this is L upon root 3 whole square. So, this is equation 3. and this value will be same as is equal to, we'll write separately first, f2 is also equal to k q upon L by root 3 whole square, and this will also be same as f3. So therefore f1 is equal to f2 is equal to f3, the magnitudes I'm talking about. Right? So if I put this in equation 2, so this is 4. So from 4 in 2, I can write f r is equal to under root of. So let's mark all these forces by f, right? So I can write this as f square plus f square plus 2f into f. I can write this as f square cos of 120. Cos of 120 is equal to cos of 90 plus 30 degree, and cos 90 plus theta is minus sine theta, so this can be written as minus sine 30 degree, so this makes it minus 1 by 2, right? So this is the reason, and here I am mentioning this as, in place of cos 120 I am writing minus 1 by 2. So this force resultant will be f square plus f square minus f square. Why so? Because this 2 and 2 will be cancelled. What will I get? f r is equal to under root of f square is equal to f, right? So if we look at the figure, our figure says that this is the direction of f r and this is the direction of f2. We know by this terminology that f2 is f and fr also comes out to be f, right? And if this is in this direction, this is in this direction, these are in opposite direction. So if I mark the upward direction as r cap, then this direction will be minus r cap. So f net on q will be vector sum of fr plus f2. So how will I write it? This will be f into r cap plus f into minus r cap, because this magnitude is also f and this magnitude is also f, but the direction of this vector is r cap and this vector is minus r cap. So this gives me 0. So I can say that f net on q is equal to 0, right? So you can see that how the use of parallelogram law and trigonometry can make the numericals very, very simple for you, right? So we'll take the next question after rubbing the board. Now we are taking example 1.7 of NCERT. The previous one was 1.6. Consider the charges Q, Q and minus Q. Again placed at the vertices of an equilateral triangle as shown in the figure. What is the force on each charge? You have to find the force on each charge. So this is also an equilateral triangle. The first step while doing the questions based on superpositions principle is always to mark the directions of the forces based on the attraction or repulsion as the case may be. So let's mark that this point is C, this is A, and this is B. Let's mark the same points as given in your NCERT. Right? Now we have to find the force on each due to the other one. So let's mark this also. This is suppose Q3 is equal to Q. This is Q1 is equal to Q, and Q2 is equal to minus Q. Now they have taken this one as minus Q and this one as plus Q. So the charge at C is taken as minus Q. I've drawn the same polarities just to make the thing simple for you. The side is L. Now I have to mark the forces on each charge due to the other two charges. So if I have to mark the force on charge 1 due to 2, both are positive. So this charge will repel it. So force on this due to this will be repulsive. So this will be the direction of force on 1 due to 2. We can write a bigger suffix. Now we have to mark the force on this first charge by the third charge. Now this one is negative, this one is positive. So this charge will try to bring it towards itself. So what will be its role? Its role will be to attract the charge 1 towards itself. So I can say that this is the force on 1 due to 3. Right? Now I can mark the force on 3 due to 1. Both are unlike charges. So 1 will also try to bring it towards itself. So this will be the force on 3 due to 1. So the first charge will try to bring it towards itself. Right? Similarly, force on 3 due to charge 2. These are also dissimilar. So this charge will also try to bring it towards itself. So the direction of force on 3 due to 2 will be this. Now, force on 2 due to 1, both are like charges. So this charge 1 will repel it away from it. So this will be the direction of force on 2 due to 1. Right? Now, force on this due to this charge will try to bring it towards itself. So this will be the force on 2 due to 3. Right? So we have marked the directions of the forces on each charge due to the remaining two charges. You have to find the net force on each charge. What will be our steps? We will have to find the resultant of this and this to find the net force on this charge Q1. So what will be the direction of resultant according to parallelogram law? The direction of the resultant will be along the diagonal of this parallelogram. This will be the net force on first charge, which is the resultant of this and this. So I can draw a diagram here also. And for this and this, what will be the resultant? Again, the diagonal of these two, which will be here. The resultant of these two forces will be along the diagonal of these two vectors. So this will be F2 and this will be F3. To make the things clear, I am drawing these three cases separately here. Right? And if we complete this parallelogram, the diagonal will give you the resultant. We can use mathematics to show that this direction and this direction is parallel, right? How? We can take a longer way, but for now I am telling you, using mathematics it can be shown that this direction is same as this direction is same as this direction, right? So we'll mark the directions accordingly. Now for finding this resultant, what will be the angle? See, this is an equilateral triangle, so this is 60 degree, this is 60 degree, and this is also 60 degree. So what will be the remaining angle? The remaining angle will be 120 degree in this case and 120 degree in this case. Why we have written these angles? Because we know that when we use the parallelogram law of vector addition, we need the angle between the two given vectors. So in this case, we have got this angle between these two vectors, that is 120 degree, this angle between these two vectors, that is 60 degree, and this angle between these vectors, that is 120 degree. Now we need to write the magnitudes of F12, F13, F31, F32, F23 and F21. So let's write down the magnitudes. F12 magnitude will be K Q into Q upon L square, right? Similarly, magnitude of F13, we are writing simply magnitude because we have marked the direction according to the polarity of the charges. So we will take here only the magnitude of the charges. So F13 magnitude will also be, F13 is this K Q Q upon L square. So this will be same, and this will also be same as F31, because here also k q q upon L square. This will be same as F23. F23 is this k q q upon L square, because we are taking only the magnitude. Similarly, this is also equal to F21. F21 is this. So k q q upon L square. So let's mark all these. Have we marked all? 1 2 2 1 1 3 3 1 2 3 and 3 2 also. So F32 will also be same, and let's mark all these by F. Right? Now this can be written as kq square upon R. L. Right? So now we can find the resultant force in each case. This we are marking as F1. This we are marking as F3, and this we are marking as F2. Right? So how will we find the magnitude of F1? This will be under root of first force square, that is F12 square plus F13 square plus 2 F12 F13 cos of 120 degree. This is the first case, and we can write all these formulas here parallel for each case. So this will be F2 is equal to under root of F31 square plus F32 square plus 2 F31 F32 cos of 60 degree. Right? Similarly, for third case, this is F3. We have marked this by F3. And for this, F2 magnitude will be under root of F23 square plus F21 square plus 2 F23 F21 into cos of 120 degree. Right? We will solve. We know that these are the magnitudes only. So we can replace all these without suffix, and we can replace it by F. So what will I get? F1 is equal to under root of F square plus 2F square. Cos of 120 is minus 1 by 2, because cos 90 plus 30 is minus sin 30, and sin 30 is 1 by 2, so this makes it minus 1 by 2. Similarly, F3 can be written F square plus 2F square, and cos of 60 degree is 1 by 2. Right? Similarly, F2 can be written under root of F square plus F square plus 2F square. Cos 120 is minus 1 by 2. Right? I hope the things are easy to understand. So this will be cancelled. This will be minus F square and F square cancelled. So this makes it F. F square minus F square, and this makes it F. And F2 will also be F. And F3 will be under root of 3F square, or you can say F root 3. We can write these values. This is the magnitude. So F1 vector will be kq square upon L square if the direction of F1 vector is taken as R1 cap, right? We can show the directions like this, that if we have this is the direction of F1 vector, this is the direction of F2 vector, and this is the direction of F3 vector, which is n cap, right? So we'll write these vectors in the form of R1 cap, R2 cap and n cap. So therefore F2 cap will be k q square upon L square, and this will be R2 cap. F3 vector will be F root 3 into n cap. That means k q square upon L square into root 3 into n cap. Now if I have to find the resultant, in this question we were supposed to find F1 vector, F2 vector and F3 vector only, but they have left one part in NCERT for you to solve. So where we can find the net force. Net force F net of all these three will be the vector sum of these three forces. For this, we can draw another diagram where we can show that this is the F1 vector, this is the F2 vector and this is F3 vector. The angle between these two can be geometrically shown to be 60 degree, and their resultants can be calculated. Resultant of F1 and F2 can be calculated using parallelogram law. So total F net is F1 plus F2 plus F3 vectors. Then we can write it like this: Fr vector plus F3 vector. This is F net vector. Now Fr can be written as this is the resultant of F1 vector and F2 vector. So this can be written as magnitude of this Fr can be written as under root of F1 square plus F2 square plus 2 F1 F2 cos of 60 degree. So this is, we know that these are F1, F1, F2, are equal to f. So f plus f square plus 2f square cos of 60 degrees 1 by 2. So this makes it under root of 3f square. This makes it f root 3. So this gives me f r vector is equal to f root 3 into minus n cap, because this is in opposite direction. So I can mark here that this is f r vector which is along minus n cap direction, and this was f 3 vector which is along n cap direction, and we know their magnitudes are same. So this is equal to f root 3 minus n cap, and this is f root 3 n cap. So the resultant comes out to be the f net comes out to be 0. So this was all about this numerical. That's all for now. Have a nice day.